Hello everyone, welcome to Chem Academy. Today in this video we are going to see CSIR-NET Organic Spectroscopy previous year questions. This video contains CSIR June 2017 and CSIR December 2017 previous year questions. Now first question from CSIR June 2017. So in this question we have to find out this signal appeared in a carbon-13 spectrum. Okay, for this DMSO D6. This DMSO D6 indicates that this DMSO is having total 6 deuterium atom. Okay, so correct structure of this compound is sulfur. Okay, and here CD3. Now this signal is appeared at delta value 39.7 ppm. This indicates that our carbon is sp3 hybridized atom. Okay, and for this sp3 hybridized carbon atom there is coupling between this carbon atom and deuterium atom. So there are total 6 equivalent carbon atom, 6 equivalent deuterium. Okay, but here signal is given due to carbon deuterium coupling in each carbon atom. Okay, so here total number of deuterium atom are present in each carbon equal to 3. So spin multiplicity will be calculated by using 2ni plus 1. Okay, here I is the spin multiplicity of deuterium. So 2 into 3 into 1 plus 1. If you calculate this value, then it will be 6 plus 1 equal to 7. So our compound will give septate. Hence correct answer will be the septate. Now this question is from CSR June 2017. So in this question we have to find out the correct structure of the organic compound. Now this IR absorption at 1736 indicates that our compound is the ester. Okay, so if you look at our all the option, all the compound are the ester, so all option might be correct. Now just check the next. Now just check the proton NMR data. So in this case the delta value 3.59 singlet for 3s. This indicates that our compound contain OCS3 functionality. So only option 3 and 4 having OCS3 functionality. So option first and second are the incorrect. So 3 or 4 might be correct answer. Now next we have to check the option 4 should give the signal for 1h. Okay, for this 1h proton. But if you look at our NMR data, there is no signal for 1h. Okay, all these are the signal for 3h and 2h. So option 4 is incorrect. So option 3 is the correct answer. Now next question from CSIR June 2017. So in this question they given the G factor for the proton and G factor for the nitrogen atom. Also they given the frequency at which this proton is resonated at 700 megahertz. Okay, so we know the relation between G and frequency is directly proportional. So just find out the relation, that is G of proton divided by G of nitrogen equal to this frequency of proton divided by G factor for frequency for nitrogen. Okay, here we know the relation between G and frequency is directly proportional. So the relation is G value for proton divided by G value for nitrogen equal to frequency of proton divided by frequency of nitrogen. Just rearrange this equation to give the frequency of nitrogen equal to this frequency of proton divided by this G factor for proton into G factor for nitrogen. So just put all this value, then we will get the frequency of nitrogen equal to this 700 into G factor for nitrogen is what, 0.4 divided by 5.6. So this value will be equal to 50 megahertz. Okay, so our correct answer will be the 50 megahertz. So option 4 is the correct answer. Now this question is belong to the mass spectrometry. So here alpha, beta and gamma. So this gamma proton will undergo the rearrangement to give the following fragments. Okay, so here this this bond, pi bond will attack on this proton, then this bond will break here and this bond between alpha and beta carbon will break. So we get this fragments like OH, okay, plus this alkene. So this fragment having the mass m by z value 72. Okay, so our correct answer will be the first. Now next question from CSIR December 2017. In this question we have to find out the total number of signal appeared in proton decoupled carbon-13 NMR spectra. So to give the correct number of structure, we have to find out the total number of equivalent carbon atoms. So here two types of plane of symmetry are present, this and this. So just find out the total number of equivalent carbon in only one quarter. So it will give our correct answer. This is first type. Okay, this is second, third, fourth, and this is fifth. So the total number of equivalent carbon atom are the 5. So our answer the compound will give total 5 signal in proton decoupled carbon-13 NMR spectra. So option first is the correct answer. Now next question from the CSIR June December 2017. In this question we have to find out the correct order for the IR absorption. Okay, so we know that the formula for IR absorption is mu equal to 1 upon 2 pi c in under root k divided by mu, where this k indicates that force constant. Okay, force constant. And if double bond character increases, okay, double bond character, if double bond character increases, this implies that k value increases. As a result, this frequency of absorption will be increased. So here if you look at this anhydride, so here is the oxygen atom which can donate the proton, which can donate the electron here, and it will form the double bond character higher. Okay, so at option 3 it will show higher double bond character, so it will have the higher force constant. As a result, this compound third will have the higher IR absorption. So IR absorption for this compound third equal to this A, that is 1865. So just look at this option, which compound, which option this compound third having A, that is first and third. So option 4 and second are the incorrect. Now just check the compound first. This compound first is the no oxygen atom, so it will have, it will not having the double bond character, so it having the lower IR absorption, because there is no double bond character, so force constant will be lower. As a result, frequency is the lower. So this first compound will show IR absorption at 1745. That is, for this first compound, IR absorption will be shown C, that is 1745. So if you look at this option first and third, so only option third having the first compound IR absorption 1745. So option third is the correct answer. Now next question from the CSIR December 2017. In this question we have the following NMR data. We have to match this NMR data in the following organic compound. Okay, so in this NMR data we have total 1, 2 and 3 signals. So our compound should contain 3 types of proton. So here is the first type, this is second type, and this is third type. So only option first having 3 types of proton. So option first is the correct answer. If you calculate all this, all all these options, then there are more than 3 types of proton. So all these options are the incorrect option. Hence correct answer is the first. Now next question from CSIR December 2017. In this question we have to find out the 31 phosphorus NMR spectrum. Okay, so here total our compound is the PH3 and BCl3. Okay, so if you calculate first, and they given that the coupling constant for phosphorus hydrogen coupling is greater than the coupling of phosphorus boron. Okay, so just find out the spin multiplicity for this phosphorus hydrogen coupling. So there are total 3 hydrogen atoms, so 2Ni plus 1 equal to 2 into total number of hydrogen 3, okay, into 1 half plus 1, the 2 get cancelled, so our answer will be the 4. Okay, now next part, if we calculate the spin total number of signal given by this phosphorus boron coupling, then here also 2Ni plus 1, okay, 2 into total number of boron atoms are 1, okay, into I value 3 by 2 plus 1, so here is also 4 option. Okay, but here they given that this coupling constant for the phosphorus hydrogen is greater than phosphorus boron. This implies that first there is a splitting of splitting due to phosphorus hydrogen coupling, so first it will give quartet, so it will be quartet. Now next this coupling, this splitting will be observed due to this phosphorus boron coupling. Okay, so next they also give the quartet, so signal will be like this, that is quartet of quartet. So only option C having this quartet of quartet, so option third is the correct answer. Now next question from the CSI December 2017. In this question we have to match the chemical shift value with this proton. Okay, so this proton first, that is due to this alkyne group. Okay, this having two types of region. This is positive region indicates that this de-shielding, and this negative region indicates that the shielding region. So this proton is present in the de-shielding region. So this is highly de-shielded proton, so it will having the high chemical shift value. Okay, so our compound first will give the chemical shift value higher, that is 16.4 ppm. So if you look at this our option, so only compound, the option 2 and 3 having compound first 16.4 value, so option first and 4 are the incorrect. So either 2 or the in between 2 and 3, one of the option will be the correct. Now if you look at this option third, so in this question this proton, the inside proton are the highly shielded and outside proton are the highly de-shielded. So due to this highly shielding, this chemical shift value will be lower, that is it might be negative value. So compound third will having the chemical shift value minus 0.61. Okay, so if you look at this 2 and 3, only option for second having the uh, compound third having chemical shift value minus 0.61 ppm. Okay, so option second is the correct answer. Now next question from the CSIR December 2017. In this question also we have to find out the resonate frequency for this carbon 13, okay, nuclei. So in this question they given that G factor for proton and G factor for carbon is 5.6 and 1.4, and they given the proton resonate at the frequency 600 megahertz. So we know that the relation, that is the frequency of carbon 13, okay, carbon 13 divided by frequency of proton, which is equal to the G factor of carbon 13 divided by G factor for proton. So just rearrange this equation to get the correct value for frequency of carbon nuclei, which is equal to G factor for this carbon divided by G factor for proton into the frequency of proton. So just put all this value, then we will get first G value for carbon will be 1.4 divided by 5.6 into 600. If we calculate this value, then it will become 150 megahertz. So our option third is the correct answer. So thank you guys for watching this video. I hope all these concepts are clear for you. Okay, thank you guys.